Alright guys, in this very short video we're going to wrap up 1.1 with talking about circles. Again, the real main kind of focus and the main goal of this video is to kind of recap and refresh our memory of the standard form of a circle and how do we actually write in standard form and how do we find the radius given a variety of points. So let's take a look here first and foremost. Obviously we know a circle, right? We know what a circle is. The key parts that we need to kind of think into a sec is that a point xy is on the circle if and only if its distance from the center hk is the radius r. So what does this mean? The only way that there's actually going to be a physical point on this circle is that if you test the point, any point that lies on this circle, you have to make sure that it is tested in such a way that the distance from the center to that point equals r. The minute it does not equal the radius r, that means it either lies outside or inside of the circle. Down there below, guys, we see the standard form of a circle. The point xy lies on the circle. Once again, if and only if this standard form holds true. So x minus h quantity squared plus y minus k quantity squared, which would once again, h comma k is your center point of the circle, okay? X and y stay kind of stationary with things until you're testing or solving for the radius, right? So let's take a look at a pretty basic example of how we would go ahead and find the standard form of the equation. Well, once again, we got to kind of think to ourselves, what does it represent? All right, so we know the standard form of the equation is going to be x minus h squared plus y minus k squared. So we're looking here at x minus h squared plus y minus k squared equals r squared. So the standard form of our equation is as simply put x minus 2 squared plus y plus 1 squared equals 5 squared, which is 25. The key thing is, and I teach to my geometry kids a lot as well too, is that when you're dealing with equations of the circle, because of these negatives inside of your standard form, that means it's going to be the opposite of what you see, right? So if we have a positive 2, that means we're looking at negative inside. If we have a negative 1, that means we're looking at a positive inside. So I always like to say, it's the opposite of what you see. And that holds true for all of our horizontal movements when we're talking about shifts from the parent function, when we're shifting the absolute value, when we're shifting our quadratics, our parabolas, when we're shifting our roots. All of those are hold true. It's the opposite of what you see for those horizontal shifts as well. So how do we find the distance actually of the radius itself? Well, think about it. The question says it all right in there itself. The distance. Well, hopefully you're putting two and two together, that there's a resemblance now between the distance formula and the standard form of a circle. And it really is. There is a huge relationship. The distance formula is simply just the standard form of the circle. So what I would like you to go ahead and do now, guys, is to answer this question down here at the bottom, and we'll be going over it first thing and on to the next one.